Hello, and welcome to another episode of Mr. Boskin Does Some Math. Today we're doing illustrative math, grade 8, unit 8, lesson 11. Okay, our first problem here says, order the following pairs of coordinates from closest to farthest apart. Be prepared to explain your reasoning. I added a coordinate plane over here just so these are a little easier to look at. Our first 2 points are the point 2,4 and 2,10. So 2,4 is here, and 2,10 is here. Try and do these in different colors. That one is black. I'll do the next one in red. -3,6 and 5,6. -3,6 and 5,6. Okay, next one here. Can I make that as small as the other ones? There. -12, -12. -12, -12 is about there, and -12, -1 is about there. Seven, 0, and 7, -9. 7, 0. And 7, -9. And then 1, -10. And -4, -10. So now let's try and figure out how long each of these are. From 2,4 to 2,10 was 1, 2, 3, 4, 5, 6 units. B, which is red, is 1, 2, 3, 4, 5, 6, 7, 8 units. -12, -12 to -12, -11 was 11 units. 7, 0 to 7, -9 is 9 units. And 1, -10 to -4, -10 is 5 units. So I counted squares. We can also work with these by looking at these points, because these 2 points, the x value doesn't change, but the y value changed 6 points. So 6. On these, the y value didn't change, but the x value changed by 8. So you can look at the graph, you can look at the actual value of the coordinate. So now, order them from closest to farthest apart. Which one is closest? E. Then A. Then B. Then D. And then C. Name another pair of coordinates that would be closer together than the first pair. So we need 2 points that are closer together than 5 units. Because you can be as creative as you want and come up with just about anything for these, I'm going to use an easy example. How about 0, 0, the origin, and 0, 1. How far away are those points? 0, 0, and 0, 1. Those are 1 unit away from each other. Name another pair of coordinates that would be farther apart. So we need 2 points that are farther apart than 11 units. How about if we went with, for this one I changed a y value, so let's change an x value. How about if we go from 0, 0 to 100, 0. Now those are 100 units apart. From 0, 0, way over. Okay. How far apart? Find the distance between the 3 points shown. The distance between those 2 points feel like there should be a negative sign there that I don't see. From negative 14, that should be negative 14, negative 3. To negative 14, 9, that's 12 units to go from negative 3 to positive 9. Now, what about these 2 points? That one's also at negative 3, but from negative 14 to positive 16 is 30 units. So now we have to find the distance between the other 2 points here. How are we going to do that? The same way we're doing everything lately, with the Pythagorean theorem. So we need to find out this hypotenuse. The legs are 12 and 30. 12 squared is 144. 30 squared is 900. Plus 144 is 1044 equals c squared. To find out c, we take the square root of each. Does that work out nicely? No, it doesn't. It's approximately 32 units, but it is exactly the square root of 1044 units. Okay. Which figure do you think has the longer perimeter? Select one figure and calculate its perimeter. Your partner will calculate the perimeter of the other. So, there are 2 figures here. I'd like us to calculate the perimeter of each of them. So for our first figure here, we have to know the length of all of these sides. None of those sides are nicely horizontal or vertical. How are we going to find out the length of them? Well, we're going to have to use the Pythagorean theorem. If we are trying to find this side first, we can imagine a point over here straight up from this lower point and straight to the left from this upper point and create a right triangle. This distance goes from -2 to +2 because the y value here is -2, the y value here is +2. That is 4 units. our x value goes from an x value of -2 over to an x value of +4, which is 6 units. So now, 4 units by 6 units, use the Pythagorean theorem. 4 squared plus 6 squared equals c squared. 16 plus 36 equals c squared. That is 52 units equals c squared. So the square root of 52 is c. This side length here is the square root of 52. Now let's do the next side we have here. This goes from a y value of -2 to a y value of -4. That's 2 units. We go from an x value of -2 to an x value of +2, which is 4 units. 2 squared plus 4 squared equals c squared. 4 plus 16 equals c squared. 4 plus 16 is 20. Which means the square root of 20 is equal to c. One last side over here. We're going to draw another right triangle by extending right from there and down from there. This goes from an x value of 2 to an x value of 4. That's 2 units. We go from a y value of -4 to a y value of +2. That is 6 units. So 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. 4 plus 36 is 40 equals c squared. So the square root of 40 is equal to c. Okay, we've used the Pythagorean theorem 3 times here. I'm going to erase those so we have space to do the other triangle. But first, let's find out the perimeter of our first triangle here. Well, square root of 20, square root of 52, square root of 40. We can't just add those square roots. Square root of 20 is 4.47. Let's just call that 4.5. Square root of 52 is about 7.2. And the square root of 40 is 6.3. Add all those up. 6.3 plus 4.5 plus 7.2. This has a perimeter of about 18. Now, another one here. Let's try and work our way through this. We're going to need right triangles again. This one goes from 7 to 8. So the x change is only 1. And y, we go from -5 to +4. That's 9. So 9 squared plus 1 squared equals c squared. 81 plus 1 equals c squared. So 82 equals c squared, so the square root of 82 is equal to c. So that side length is the square root of 82. Next side here, we go from 7 to 9, which is 2, and we go from 2 to 4, which is also 2. 2 squared plus 2 squared equals c squared. 4 plus 4 equals c squared. So 8 is equal to c squared. The square root of 8 is equal to c. Square root of 8. One more over here. This right triangle goes from 8 to 9, so this side is 1. This goes from -5 to 2, so that is 7 units. So 1 squared plus 7 squared equals c squared. 1 plus 49 equals c squared. So that's 50 is equal to c squared. So the square root of 50 is equal to c. Now let's get some decimal values that we can add together a little more easily. 82, square root is 9.05, so 9.1, 9.1 square root of 8 is 2.8, and square root of 50 is 7.1. Let's add all those together. 7.1 plus 9.1 plus 2.8 is equal to 19. So this one had a perimeter of approximately 18, and this one had a perimeter of approximately 19 because we rounded off and did not use exact values for our square roots. Which figure has a longer perimeter? This one. Let me erase some of this work so you can compare them a little bit. This one has a longer perimeter. Okay, next question. Quadrilateral ABCD has vertices of -5, 1, -4, 4, 2, 2, and 1, -1. Use the Pythagorean theorem to find the length of each side. So, let me grab a graph for us to use. And through the magic of video editing, there is our graph. A is at -5, 1. B is at -4, 4. C is at 2, 2. And D is at 1, -1. Okay. We have a quadrilateral. Ooh, that looks like a rectangle to me. Use the Pythagorean theorem to find the length of each side. So, this side here, if we look, that is a 1 by 3 triangle. 1 squared plus 3 squared equals c squared. 1 plus 9 equals c squared. 10 equals c squared. So the square root of 10 is equal to c. So this side length here is the square root of 10. Let's do this other short side. Well, this is also a 1 by 10, or 1 by 3 triangle. We already calculated a 1 by 3 triangle. This side has a length of the square root of 10. Now, let's do this longer side of the rectangle. If we draw that out, we have a 2 unit by 1, 2, 3, 4, 5, 6. A 2 unit by 6 unit triangle. 2 squared plus 6 squared equals c squared. 4 plus 36 equals c squared. 40 equals c squared. Square root of 40 equals c. So this side here is the square root of 40. Now let's do this side here. 1, 2, 1, 2, 3, 4, 5, 6. That is also 2 units by 6 units. That side will also have a length of the square root of 40. Use the Pythagorean theorem to find the lengths of the diagonals. So the diagonals of a rectangle are these, connecting the corners. So now let's find the length of each of those. This first diagonal right here looks like it goes up 1 and over 1, 2, 3, 4, 5, 6, 7. So that would be 1 squared plus 7 squared equals c squared. 1 squared is 1. 7 squared is 49. 1 plus 49 is 50. So the square root of 50 is equal to c. So this diagonal here, the length of it is the square root of 50. Now our other diagonal looks like it goes over 1, 2, 3, 4, 5 units. And down 1, 2, 3, 4, 5 units. Is that right? 1, 2, yeah. Five squared is 25. 5 squared is 25 equals c squared. 25 plus 25 is 50 equals c squared. So the square root of 50 is equal to c. So the next part of this question here is explain why ABCD is a rectangle. I don't really have space to write much underneath there, but we know the opposite sides are the same length. This side was the square root of 40. This side was the square root of 40. This side was the square root of 10. This side was the square root of 10. Opposite sides are congruent to each other. Now, that's the first piece of being a rectangle. The second piece of being a rectangle is that all of the sides, or all of the angles, are 90 degrees. All the angles are right angles. How can we prove that all of these angles are right angles? Well, if the diagonals are the same as each other, if the diagonals are the same length, then it has to be a right angle. It has to be a rectangle. If the side lengths are the same and the diagonals are the same, that's one of my favorite woodworking tricks to make sure that the coffee table or whatever you're building is square, is to check the lengths of the diagonals. Finding the right distance. Have each person in your group select one of the coordinate pairs here. Calculate the length of the line segment between them. Okay. Now, I would like us to think about this graph real quick, and then we are going to talk a little bit about a faster way to do these. So our first point is -3, 1 and 5, 7 approximately. Well, that wasn't a very good line. -3, 1 and 5, 7. So if we do our right triangle here, the length of this side, we went from -3 to 5. We just need to find the distance between those. So the distance from here to here horizontally is 5 subtract -3. What's 5 subtract -3? That's 8. How about this? 7 subtract 1 is 6. So now 6 squared plus 8 squared equals c squared. Could we solve this for c right away? Well, we could. We know we have c squared here. We're going to have to take the square root of that. So we're going to have to take the square root of the other side. So we know that the square root of 6 squared plus 8 squared is going to equal c. So the square root of 36 plus 64 is going to equal c. Square root of 100 is going to equal c. Square root of 100 is 10. So the distance between those 2 points is 10. Now for our next one, c is going to equal the square root of the square of those two distances, but those two distances we get just by subtracting our y values and then subtracting our x values. 5 subtract -1 is 6. 2 subtract -6 is 8. C equals 6 squared plus 8 squared. That looks pretty familiar. We already did that work in the middle. Let's check our next one here. C is going to equal the square root of 5 subtract -1. Well, 5 subtract -1 is 6. -6 subtract 2. Ooh, this one's going to be different. That's -8 squared. Six squared is 36. What's -8 squared? A negative number times a negative number? That's 64. We already did that. C is the square root of 100 again. C's 10. That one was 10. That one was 10. We've got one more here. 6 subtract negative 2. This one might be different. Let's check. C is equal to the square root of 6 subtract negative 2. That's 8. 1 subtract negative 5. Well, that's 6. Hey, this is the same thing as what we did before, but with the 6 and 8 backwards. 8 squared is 64. 6 squared is 36. That's still going to be 100. So C is still going to be 10. So those were all different points, but the distance between all of them was always 10. How does the value you found compare with the rest of your group? It's the same. Every one of those should have been 10 units apart. In your own words, write an explanation for how to find the distance between 2 points. Let me see if that makes it in our summary. It doesn't. I am going to quickly give us, because we're in a little bit of hurry with how much school year we have left, the formula to find the distance between 2 points. So if we have 2 points, each point is an x and y value. Now, you might recognize this from our slope formula. Let's call those our first x values, and those our second x value, or second x and y value. First point, second point. Now, the distance between those 2 points, that is our C value, the length of our hypotenuse between those 2 points. To find the C value, we took the square root of the other side. And how did we get these values? Well, we took the second x value and subtracted the first x value. And then we squared it. That gave us this 8. What did we do with the y values? Well, we took our second y value, subtracted the first y value, and then squared it. So this formula right here will tell us the distance between any 2 points. So if we know 2 coordinates, we can plug them into this formula to find the distance between them. And how do we do that? Well, that's just the Pythagorean theorem, but rearranged a little bit. This has been another episode of Mr. Boskin Does Some Math. Thank you for tuning in. See you next time.